Well, hey everybody, Mr. Reeves back with you in our second of two videos on lesson 18.1 in the HMH Accelerated Math 7 textbook, solving equations with variables on both sides. So in the first video, I introduced you to the idea of what an equation with a variable on both sides was and my recommended method for solving it. We looked at a balance. We also looked at algebra tiles, and we're just going to continue in this second video working through some more problems. All right, so I'm going to start right here on guided practice, page 562. I'm going to look at number 2 right here. It says to use algebra tiles to model and solve each equation, and that's exactly what I'm going to do. Number 2, 2 minus 3x is equal to the opposite of x minus 8. So if we look over here, here we go. We've got 2 plus negative 3x, which of course is the same as 2 minus 3x, is equal to negative x plus negative 8. All right, so if I were to write this equation out, again, I have 2 minus 3x. Remember, adding 3 negatives is the same as subtracting 3 positives, is equal to a negative 1x, or the opposite of x, as we often say, minus 8. And again, remember, adding 8 negatives is the same as subtracting 8 positives. Okay, so what do we want to do first? Now remember, if you're taking Mr. Reeves' advice, even though you have many options, my advice is to find the variable term with the smaller coefficient, all right, and eliminate that one. So what do we have here? We have a minus 3x and we have a minus x, and remember, this is the same as negative 1x, right? So negative 3 is smaller than negative 1. So this is the one I want to eliminate. Well, how do you eliminate subtracting? Well, we take it away, right? Taking away a negative 3x from both sides is what we want to do. But subtracting a negative is the same as adding a positive. So what do we want to do? We want to add 3x's to both sides. So that's exactly what I'm going to do. All right, here we go. 1, 2, and 3. But whatever you do to one side, you want to do it to the other side. 1, 2, and 3. So I added 3x's to both sides. And what happens when I add those 3x's to both sides? They cancel, don't they? And what am I left with? I'm left with 2 is equal to, what happens over here, 2x minus 8, right? So if we go here, here we've got it. Cancel out, cancel out, cancel out. That gives me 0. That one's going to cancel out. All right, I'm going to move those up there. All right, and what do I now have? I now have 2 is equal to 2x minus 8, right? Well, now I have a two-step equation, don't I? All right, the opposite operations in the opposite order. Going forwards, they multiplied by 2 and subtracted 8. So going backwards, we're going to add 8 and divide by 2. All right, so here we go. I need to add 8. All right, so this is going to be a little bit of a process. So I'm going to use this copy feature here. So there's 1, 2, 3, 4, 5, 6, 7, 8. All right, then I'm going to put 1 down here and do the same thing. That's 1, 2, 3, 4, 5, 6, 7, 8. All right, I added 8 to both sides. All right, so if we go back to where we were, right, we had 2 is equal to 2x minus 8. And what did we just do? We added 8 to both sides. Well, what's going to happen? Well, 2 plus 8 is going to give us 10, and we're going to get 10 is equal to 2x, right? What's going to happen with these 8 yellows and these 8 reds? Well, we're making a bunch of zeros, aren't we? All right. And so now what do we have? All right, now we have this equation right here. We've got 10 is equal to 2x, right? We've got right here, we've got 10 is equal to 2x. So what do we need to do? We need to divide both sides by 2. And when we're done, we're going to get 5 is equal to x, or x is equal to 5. So with algebra tiles, what we do is we break them up into the number of groups we need, in this case, which is 2, right? Let me do that, and then we usually like to make it look nice. So we can rotate it like that and line that one up that way and rotate it that way. And you can see that when 2x's are equal to 10, then 1x is equal to 5, right? 2x equals 10, 1x equals 5. There's our solution that we had right there. So we can write, right, x. So this was 2x equals 10. So 1x equals 5. There we go. All right, so that is an example of solving a problem using algebra tiles. We got x was equal to 5. And of course, it's always a good idea to check your answer, isn't it? All right, so we can know if we did it correct. 2 minus 3 times 5 is equal to the opposite of 5 minus 8. All right, using order of operations, we're going to multiply first. So 2 minus 15 equals minus 5 minus 8 is minus 13. What's 2 minus 15? Negative 13 equals negative 13. It checks. That means that my solution is correct. Yay! Okay. All right, so let's do a few more of these ones here. All right, how about if we look at number 7? I want to do some of these ones that have these negative coefficients because they tend to be the ones that cause us some more problems. All right, the opposite of n plus 5 is equal to n minus 11. All right, so which one has the smaller coefficient? Do you agree that negative 1 is smaller than positive 1? I hope you do, right? So what am I going to do? I'm going to add a positive n to both sides. That's going to eliminate the variable term that has the smaller coefficient. Remember, I could subtract a negative n, but subtracting a negative is the same as what? Adding a positive. So to eliminate terms with negative coefficients, we simply add the opposite. So what do I get? I get 5 equals 2n minus 11, and now I simply have a two-step equation. So I'm going to do the opposite operations in the opposite order. They multiplied by 2 and subtracted 11. So what am I going to do? I'm going to add 11 first, giving me 16 equals 2n. 2n, Mr. Reeves. 16 is equal to 2n. And then I'm going to divide both sides by 2, and I get 8 is equal to. And then, of course, it's always a good idea to check your answer to make sure that you did it correctly. Not that you make nearly the mistakes that Mr. Reeves does, but here we go. All right, negative 8 plus 5. Well, what is that? That's negative 3. 8 take away 11. Let's see. That is also negative 3. It checks, which means that my answer is correct. All right. Okay, let's do one more, shall we? I'm trying to look for one that I did not do in the previous video. All right, I'm pretty sure I did not do number 8 in the previous video. All right, it does not have negative coefficients, but we'll go ahead and do that one. 5p plus 8 equals 7p plus 2. All right, find the one with the smaller coefficient, the variable term. There's 5, there's 7. What's smaller? 5 is smaller, so I'm going to take that away. When I subtract 5p's, those cancel. I get 8 is equal to 7p minus 5p is 2p plus 2. And now what do we have? We have our two-step equation, so we're going to do the opposite operations. In the opposite order, they multiplied by 2 and then added 2. So we're going to subtract 2. And then we're going to divide by 2, giving us 3 is equal to p, right? So now we can go back up to our original equation and we can check it. 5 times 3 plus 8 is supposed to be equivalent to 7 times 3 plus 2. Is it? Well, 5 times 3 is 15 plus 8. 7 times 3 is 21 plus 2. 15 plus 8, 23. 21 plus 2, 23. It checks. What does that mean? That means that our answer is correct. All right, what about a few of these word problems here? All right, so again, we're having equations now that have variables on both sides. So we did a lesson on writing and solving two-step equations previously. All right, so now we're going to be applying that, but now we should get equations that have variables on both sides. Remember, the variable goes with the part that's reoccurring. In this case, at a Silver Gym, membership is $25 per month, and personal training lessons are $30 each. At Factor membership is $65 per month, and personal training sessions are $20 each. In 1 month, so we're looking only at 1 month. That's important to understand. Okay, in 1 month, how many personal training sessions would Sarah have to buy to make the total cost of the 2 gyms equal? All right, so what are we looking for? What is it that we don't know? All right, how many personal training sessions? That's our variable. We're going to call that X, okay? So even though this is a monthly fee, if we were working on a year, if we're looking at a year, that would be a reoccurring cost. But we're only looking at 1 month. So that's a one-time cost, right? So what do we get here? We get $25 in that 1 month plus $30 for every personal training session. Now, how many personal training sessions are we doing? We're doing X personal training sessions. All right. Fit Factor, it's $65 per month. So it's quite a bit more per month, $40 more, but those training sessions are only $20 each. All right. So it's $40 more per month, but the training sessions are $10 less. We want to make those equal, right? So here we go. There's our variable terms. Which one has the smaller coefficient? 20 is smaller than 30. So we're going to take away that 20x, all right? And so when we do that, sorry, I don't have room to go down. I'm going to go over here. I get 25 plus 10x, right? That's the difference in the cost between those training sessions is equal to 65, right? And now I have my two-step equation, opposite operations in the opposite order. We would have multiplied by 10 and then added 25. So what are we going to do? We're going to subtract away that 25. 10x is equal to 40. So do you see what we've got now? That $40 difference in the initial cost, that $10 difference in the training session. How many training sessions is it going to take to make up for that? And the answer is 4. So for 4 training sessions, the total cost at the 2 gyms would be equal. And of course, we're going to check our answer. 25 plus 4 times 30. Does that actually equal 65 plus 4 times 20? All right, well, 4 times 30 is 120, so this gives me 145. All right, 4 times 20 is 80 plus 65 is 145. All right, so those are equal, which means that my solution is correct. All right, so the answer is not actually x equals 4. The answer is 4 training sessions. Remember, when you are answering a word problem, that you should actually get the units on there, okay? All righty. A moving company charges $8.40 plus $17 per hour. Another moving company charges $7.60 plus $22 per hour. How long is a job that costs the same no matter which company is used? All right, so once again, how long? That's our variable. That's our time, right? Okay, so per hour, that's going to be our variable. So if we take the first company is 840 plus 17 per hour. So I'm going to put that X on there, is equal to another moving company is 760 plus 22 per hour. Okay, we want those to be the same. Find the variable term with the smaller coefficient. Do you agree that 17 is smaller than 22? I certainly hope you do agree with that. And I get 840 is equal to 760 plus, what's 22 minus 17? I believe that's 5, right? And now we have a two-step equation. We're going to solve it using the opposite operations in the opposite order. Going forward, we would multiply by 5 and then add 760. So going backwards, we're going to subtract that 760 away. That's going to give us the difference in the costs of these first initial costs, right? 840 minus 760. Well, 860 minus 760 would be 100. We've got a difference there of 20, so I believe that's going to be $80, right? $80 is equal to 5x. So this company here charges $80 more, right? This one here charges $5 less per hour. If we divide by 5, well, 80 divided by 10 would be 8, so 80 divided by 5 would have to be 16. So I got an answer of 16. So the question is, are these equivalent? Does 840 plus 17 times 16, is that going to equal 760 plus 22 times 16? All right, so at this point, I'm going to go ahead and get out my handy dandy calculator and use it to help me out. So 840 plus 17 times 16, that is 1,112, in this case dollars. All right, 760 plus 22 times 16, fingers crossed, 1,112. So it does check. All right, so what does that mean? 16 hours, remember when you're answering a problem, put those units on. 16 hours will cost the same. This company charges more to start, but less per hour. This one, less to start, but more per hour. If you go 16 hours, it won't matter which one that you use. All right. Okay, I think I'm going to stop. Actually, let me do a couple of these ones that just have the numbers. All right. And then we'll be done. All right, 2 less than 3 times the number is the same as the number plus 10. All right, so I'm going to use the variable n. Now remember, less than tells you to subtract from. So this is not 2 minus 3n. This is going to be 3n minus 2 is equal to that number plus 10. All right. I'm not going to actually go through and solve this. I'm just going to write them. Just to let you know, though, we would subtract the 1n from the 3n, right, and work from there. All right, a number increased by 4 is the same as 19 minus 2 times the number. So the number increased by 4, n plus 4, is the same as, that means equals, 19 minus 2 times the number. So this one, it just used the word minus, so we are going to go in that order. And finally, last one, 20 less than 8 times the number. Again, 8n minus 20. When you see less than, it means subtract from. 20 less than 8 times the number is the same as 15 more than the number. All right, and again, then you would just use the processes that I've gone over in both this video and the one before it to eliminate the variable term with the smaller coefficient, which will create either a one-step or a two-step equation, which you then will solve because you are experts at solving two-step and one-step equations, and now you are expert at solving equations with variables on both sides. But if you're not feeling like an expert and you need more help, never hesitate to let me know. Have a great day. Until next time.